data scientists spend roughly 60 to 80% of their time on data pre-processing tasks. I'm telling you, that's the fact that any practicing data scientist is going to attest to. Welcome, my name is Oluwasegun Adebayo and I'm a data analyst. Now, today I will be walking you through different types of missing data, scenarios on how to deal with them appropriately. So I will explain each of the scenario based on my practical experience working on data. So please, you've got to watch to the end of the video to grasp the key concept. Now, before I proceed, could you please just subscribe to our channel? We really need that, Thank you. Now let me give you some statistics about missing data. It's a serious one though. It's a serious issue. Missing data is a serious issue in data analysis and machine learning model development. Now, did you know that data scientists spend roughly 60 to 80% of their time on data cleaning, transformation, and pre-processing? Secondly, nearly 30% of data in various industries contains missing values. Now, what am I saying? Data pre-processing phase is crucial because the quality of the input data significantly influences the outcomes of analysis and machine learning models. Now, cleaning and pre-processing tasks include, first and foremost, such as handling missing values, dealing with outliers, normalizing or scaling features, and converting data into suitable format for analysis or modeling. I'm going to be covering all these aspects of how to deal with missing data in this video. I'm going to show you up to about 8 or 7 types of missing data that we usually have in real world dataset. So let's get into it. So the first and foremost, let's import the libraries that we're using. Import Pandas SPD, import numpy snp, then import matplot, clip pyplot as plt. Okay, then we have the magic here, matplotlib inline. Let's run. Then now let's create a sample data frame that we'll be working with. So we have ID. Okay, then we have 1 2 3 4. Then let's have value as well. Then it contains some data, 20, 30, then 40. So the next thing now is to make this dictionary a data frame so that we'll be able to work on it using Pandas. Okay, so dHave is equal to pd dot data frame, then put the data inside. So let's check the first 5 rows. So hope everything is okay. Yeah, cool. This is a sample data set. Okay, a sample Pandas data frame. So let's check something. How do we identify data type mismatch? Check this data. This is numeric, right? According to Python rule, this is a string. This is numeric. This is a string, right? So there's gonna be an issue. So when this happens, how does Python interpret it? So let's check the data types. Let's say dHave dot the types. So let's see what we have. Yeah, cool. So it tells us that the ID column is an integer, which is okay. And the second one here, the second column, which is value, is telling us that it's an object. You cannot proceed and move on to do any further analysis or develop machine learning model with this data. You've got to work on it. There's an issue of data type mismatch. So, and how do we handle that? Because this should be an integer as well. This should not be an object. So when this happens, how do we handle it? One way to do that, okay, is very simple. It's just to convert it to numeric, the column that you're having issue with. And how do we do that? Just say df, then the name of the column. Name of the column is equals to pd dot to numeric. So this is the function we use. So to numeric, then you specify the name of the column again. Then there's an argument you have to put. Errors is equal to coas. Now, before I proceed, let me explain what this argument actually means. I'm assuming that you're a beginner, but of course, just let me quickly explain. So the error parameter allows you to specify how to handle errors that may occur during the conversion process. Now, setting the error to be this option means that if there are any errors encountered during the conversion from object to integer, Pandas will replace the problematic element with what we call NAT, not a time values, rather than erasing an error and halting the process of execution. Okay, so basically that is what that means. Now let's check after this line of code. Let's check the D types again, and see if anything has changed at all. So cool. So after running this line of code, which basically forced this column to be integer, and this is reasonable because what you actually have here is actually a number. Okay, but if it's a text, you might have issues. So this is a number, so that we've actually identified as strange. So it forced the whole value here to be a numeric value. Okay, so basically that is how to solve data type mismatch when you have such in your real world data set. Okay, so the second scenario that we'll be working on right now is what we call missing data. Okay, let me copy this data to so that we can make use of it again. Control C. Okay, then let's change something. Let's put here, let's put none. Okay, let's turn this to numeric. So this is another type of issue in handling data, missing data. So let's run it and see what we have. So now we have now. This is very, very common in real world data. So we have noun in this issue. So how do we handle this issue right now? There are two ways that you can deal with it, with this type of issue. One way is to drop this row so that you'll be left with only 3 rows. Another way is called imputation. That is when you input, like you substitute a value for this noun. It could be media of this column value. Okay, so the choice is yours based on what you are working what you are working on. Okay, so I'm going to be showing the 2 steps here. Now df, let's say df is equal to clean. df is equal to clean is equals to, and what we just do right now is that df dot, we use the function df dot drop now. Then we put the data. Let's see what we have in data clean. Oh, there's an issue here. No, we shouldn't put anything inside this function. Cool. So this is the new data set, which is df clean. So it has already removed the row containing noun. So another option is the imputation. So in the imputation part of this issue, I'm going to be using the function called fill noun. So it's going to fill the noun value in our data with a particular thing that we want to substitute those noun values for. So and how do we do that in Pandas? df is equal to df dot fill noun. Okay, then then put the name of the column. Okay, value. Then what am I filling the noun value for? Let me say main, the main value of that column. So let's check the data. Yeah, cool. So that's actually substituted the average of this column for the noun values. So if we have more than one noun value in this column, it will have just substituted the average value for each of the noun value. It could be media, it could be anything you choose. Okay, so yeah, but I don't like the way these figures are looking. I don't like this 0, 0 stuffs. So one way we can solve that is using the floor function. I made a video on how to use this function, so please try to check. I made a video on floor, ceil, and hint function on how to use them. So this is one of the application of floor. So you're gonna see the link right above there. Okay, so let's run and see. So let's see what we have. Cool. I mean, this actually looks neater, right? So, so this is the function of floor that's actually cut off all the decimal values. So we have only this, and this looks much more okay, right? So basically, that is how to deal with the missing value now in your real world data. So the next type of missing data scenario right now is the unexpected values. This comprises of probably you having question mark or kind of weird stuffs in your data. So that is a case of unexpected values. So and let me copy this data again and see how to deal with that. Let's say here we have question mark. Yeah, I've encountered several cases of this where you have question mark or some character that are just weird, in your data set. So how do we deal with this? So let's check this data and see what we have. Yeah, cool. We can see question mark right here, right? This is an issue. You can't proceed with your analysis or developing machine learning model without first and foremost solving this issue. So now there is a trick here. This is actually different from the previous case in the sense that, let's say the question mark is obvious, right? Now let me check. Let me use this in operator of Python to check what is in df. Is it there? It's going to tell me false. Why are you telling me false? I can see question mark here. Those are the tricks. Sometimes some people just go ahead, check for some details, and then when they see that this is false. They assume that, okay, my data is clean, and then they proceed data analysis. No, this is an issue because of the data types. That is why this is not seeing the question mark as you are identifying it. So another thing you can do is def dot is none dot. These are ways that I use to fish out my issues, the issues in the data. So let's say we have this it's none. Sorry, so put this here. So it tells me it's 0. Okay. So should I assume that my data is okay and then I should just move on with my analysis? No, you can't. One way you can solve this issue, okay, there are 2 steps to solve it. One is, so the first step to solve this issue is to force the data frame, the data, into the column that is actually having issue, to force it into numeric, which is the solution to the first instance, the first scenario. Okay, so let's just copy. Let's just copy right from here. Let's copy, Ctrl C. So we force it. Then let's see what this will actually do is that it will change the question mark to none. So from now, you may now choose to probably remove the row or impute any value you may want. So let's check it. You can see this has actually forced this question mark, that's forced it to become a noun. So from this, you may now choose to probably remove this row entirely, or impute a value for it, and that is solved. Okay, so we're going to be move on to the next scenario. So now, before I move to the next scenario, let me check. Let's check again if none is present in this data or not. So def dot is none dot sum it up. Already now we have. So it's going to tell you that now in column value there is one noun value there. So this is an alert. Don't move on. You've got to settle it. So with this is a very good technique for me. I use it on several cases. So because dealing with missing data requires you to be very, very wise, because there are different types of them, and knowing how to maneuver your way to move from one to fish them out is a great skill in data analysis and machine learning. I mean, in any data field, actually, it's very, very essential. So yeah, so basically that is a tactics. So let's move on. So the next scenario that we'll be dealing with right now is called categorical data encoding. So in most of the real world data, you're going to encounter categorical variables in your data. So, and you may want to develop a model that will make use of that variable. So you cannot how do I call it now? You cannot model with categorical data. So the one thing you can do is to encode them. So, and in categorical data encoding, usually we use one-hot encoding technique. And what's the meaning of this? One-hot encoding technique in data analysis is the conversion of categorical information into a format that may be fed into machine learning algorithms to improve prediction accuracy. So this is very good when you have your features being on the same data type, like they are all integers. So you've just got to do every single thing possible to minimize error in your modeling. Okay, so that is when the categorical data encoding comes into play. So we're going to be demonstrating that on how to deal with them. So in this case, we've got to create a noded set. So let's say we have data equals to, let's create a dictionary. We have category, probably a category of product or something. Then we have A, we have B, then we have let's say we have A again, then we have C, okay. Then we have price of each of this product category, okay. So let's say the price is 35, we have 43, 56, and 30. Then let's convert this dictionary to data frame, to pd dot data frame, then putting this. Let's see what we have. First 5 row. Yeah, cool. So this is what we have. This is a categorical variable, okay, categorical feature, and this is a numeric feature, right? So, and we want to develop a machine learning model that will make use of this categorical column. So one way we can deal with that is what we call one-hot encoding. How do we do one-hot encoding? Let's say we use Pandas get dummies function. Okay, let's say we have df encoded is equals to pd dot get dummies. Yeah, cool. This one. Then what we now do now is that we supply the data itself. Then the column that we are interested in, columns is equal to the name. Excuse me. The name, category. Okay. Category. Then I like to use this. It's just an additional preface if you want. It's just an additional agreement. So preface means that it will add the name of the column as a preface to each of the encoded value. So it's equals to category. Okay. So let's see what we have in encoder. Yeah, cool. So this is the new data set, right? This is the new data now that we're dealing with. So it has actually encoded each of these A, B, C into new set of columns. So meaning that A is here. There's no. So with this now, you can actually proceed to develop your model using this column as features. Okay. So now let me chip in one frequent interview questions that I've encountered in I think in 3 interviews now. Yeah. So the question is what is the difference between label encoding and one-hot encoding? I repeat, what is the difference between label encoding and one-hot encoding? It's a 2 different things entirely. Okay, so put down in the comment. I would like to see your response. So what is the difference between the two? Okay, put down in the comment. I'm going to be telling you the answer at the later in this video. Okay. So the next scenario right now, the next issue that you may encounter while dealing with real-world data is what we call scale inconsistencies. So this is very, very common when you are developing machine learning model. So when you have a column having hundreds or thousands in scale with another column that is probably 0 point something in like tenths of on a 10th scale or something like that. So when you develop your model with such a huge difference in scale, so you're going to have issue. So for instance, let's have this data. So this data is, let's say the first feature you want to use is on this scale. We have 100, we have 200, 300, 400, right? And then you have the second feature, which is the second column now, okay? You have 0 0.1, 0 0.5, 0 0.9, 2.0. So now let's convert this to data and then let's see what we have in the data. So cool. So this is feature one, this is feature two, and I want to develop a machine learning model with these two columns. I'm going to have high level of errors in my model if I go ahead to do this, because this column feature one would actually have higher influence on the model than feature two, and we don't want such a thing. We want the two columns to actually perform on based on their real content. Okay, so I'm going to be showing you on how to handle this shortly. So one way to solve this is to use the standard scaler of scikit-learn preprocessing. Okay, so first and foremost we have to import it from sklearn dot preprocessing, import standard scaler. Okay, so with this, let's move on. Then so now let's initiate the standard scaler. Let's say standard scaler. Okay, let's assign it to variable scalar. Then what we need to do right now is to select the columns that we want to fit together, that we want them to be on the same scale. Okay, so we have feature one, right, and feature two. Okay, then the next thing now is to use scalar to fit it. Excuse me. Scalar dot fit transform dot transform. Then we indicate the columns, which is what we have here. Just copy and paste right here. So now let's check the data again and see what we have. Oops, we have an error here. And where is that from? Oh, not in the index. Oh, I actually misspelled it. This feature. Let's see. Yeah, cool. So we can now check this data, compare this data with what we have up here. There's a difference. Whereas it is actually the same thing. It's the same. We have the same information is actually within the same information. Nothing has changed about the information that we have in the data. So just that it actually changed the scale. So this is one way that I usually use whenever I have this type of issue of scale inconsistency. So another interview question that of course I've encountered in in several interviews that I've had is this question of why and when do we use standard scalar in data analysis or machine learning? Put down your answer in the comment and let's see. So why and when do we use standard scalar in data analysis? I've actually answered the question in my explanation, so let me know. Let me see if you're actually following what I've been explaining thus far. So let's move on to the next scenario. So the next step we're dealing with right now is what we call the inconsistent format. So this usually occurs in time series data where you have uh, date column being of different formats. People, maybe some people using hyphen, another set of people use slash and the likes. That is an example of inconsistent format. So, and I'm going to be using this data. So now this data, it has two columns, date and value. Okay. So we have, this is one response using Ivy. This is another one using slash. Sorry, yes, slash and the likes. So let's convert this data to data frame. Sorry, let's check what we have inside this data. So this is what we have, and this, you cannot proceed with this kind of data. You've got to do something about it, about this column of dates. So this is very easy to deal with in Pandas, and one way you can do that is to select the name of the affected column, which is date is equal to, then we use pd dot to date time. Okay, then you specify the name of the column again. So let's check what we have right here. So we have a different nice looking date column using the same format of Ivy. Okay, so this is basically how to solve this issue of inconsistent format in Pandas. Okay, so now one key thing that I would like to let you know about the importance of what we just did in inconsistent format is that now we use this function pdate to data time to date time to convert this the date column to a date time format. Why? This ensures that dates are consistently formatted, making it easier to work with and analyze temporal data, such as let's say you want to do time series analysis on a particular data. So having it in a date time enables you to be able to do all the necessary slicing by time, date, year, or whatever data that you are actually working with. So that is one importance of having a consistent format in your data. So I'll be giving a recap on the different types of missing data that I've covered in this video. And the first one talks about data type mismatch. So, and how can we deal with this actually? One solution is what we call casting data types. So in data cleaning processes often involve converting or casting data types to ensure consistency. So that is one thing you can do to this kind of issue. Okay. So in the second case, which is missing data, is very, very common. So like some entries in the data set may be missing for various reasons. Okay. And there are different ways that you can deal with this. The first option is what we call deletion. So that is removing rows or columns with missing values. Second option is what we call imputation. Imputation means filling in missing values using statistical methods, such as you substituting mean, median, or mode. And machine learning algorithms could be used as well, or domain-specific knowledge. It depends on what you are aiming for your data. Then the third option, okay, which is often used in scientific application, is what we call interpolation. So this involves estimating missing values based on the values of neighboring data points. So people in the scientific area like me, so I use when I'm working with the scientific data, so we use interpolation a lot. So to solve issue of missing data. So for the unexpected values, entries may contain, like in your data now, you may have some unexpected values that do not conform actually to the expected data, like the range or even the category, such as the case of question mark. Then one way you can solve this is cleaning and validation processes could be implemented to identify and handle unexpected values. This may involve such as removing or inputting such values. Okay, in our case, we actually substituted average of the column. So that is one way which is pretty much accepted in data analysis. So the fourth scenario that we talked about is categorical data encoding, and issues with this are actually now this is the truth. Categorical variables may be represented in various ways, such as strings, integers, or other format. And one way that you can solve this is by standardizing the encoding of categorical variables. Okay, so in our case now we use one hot encoding, right? So one could use one hot encoding, one could use label encoding, or even using more advanced methods like embedding. So it depends on you, on the goal of your data analysis. So what you want to achieve will determine the method you will use when dealing with categorical data encoding. Now, in the fifth case that we talk about, which is scaling consistency, numerical values may be on different scales. That is normal. That is very, very normal. So, which can affect certain algorithms. So, having different scales actually could be a big issue for us while analyzing data or developing machine learning model. So, and solution to this could be one, standardizing or normalizing numerical features can mitigate scale related issues. And the techniques that one could actually use could be minimum maximum scaling, also called a min max scaling, or set score normalization, or I mean based on your goals, you choose which method to use and when to use it. Yeah. So you could use min-max, could use set score normalization based on your choice. Okay. So and the last the last scenario we actually talked about is the inconsistent format. Data may be inconsistently formatted. It is normal. So for instance, date format may varies within a data set, just like in our case, some people using hyphen, some using slash. So solution, standardizing format during data preprocessing helps ensure consistency. Libraries of different types could be used. Like in this one, we actually use Pandas, so which is pretty much easy. So PD dot to data time, and it actually did the magic for us, and we have this nice looking date columns. So of course there are many other issues, but I can assure you that this is the most common issues that we have in a real world data set. Okay, so and there could be an issue of duplicate data as well, which will just be you removing them, completely. And another issue that you could have is what we call data integrity issues. These are more of theoretical stuffs, not really practical, you know. So like data may have integrity issues such as inconsistent relationship between tables in let's say a relational database now, you know, and integrity is also another issue that we usually have in real world data. So this is all what I have for you in this video on how to handle missing data in Python. So, and I hope you've learned one or two things. Please kindly subscribe, like this video, share this video, comment, and this is one way to actually appreciate what we are doing, our time to create this kind of content for sure for free. So please kindly subscribe to our channel. And in summary, dealing with inconsistent data types involves first and foremost data cleaning, data transformation, data standardization, and handling missing data requires careful considerations. An appropriate imputation method based on the nature of the data and the analysis goals. I always mention that based on your analysis goals. So what you are aiming to achieve from your data determines the type of method you will use in each step of your analysis. You must have that at the back of your mind. Okay. So back to the interview questions that I stated earlier. So the first question says that what is the difference between label encoding and one-hot encoding? Now, the difference between them actually is that one-hot encoding generates several binary columns, just as we have in our case here. Let me see. I'm trying to check for where. Yes, so it generates several binary columns such as this based on the number of distinct categories, that is such as A, B, C. If we have up to A to Z, it's going to create columns of A to Z. So that is for one-hot encoding. Whereas label encoding only generates a single column for the categorical variable. So for the label encoding, it's going to include every single encoded value into a single column. So that is the difference. So if you don't need to memorize anything, that is just the difference between one-hot encoding and label encoding. One-hot, it creates multiple columns based on the distinct categories in that column, while the label encoding creates a single column. Simple. So to the second question. So what's the second question actually states that why and when do we use standard scalar in data analysis? Now, I believe I actually mentioned it. I actually mentioned it while I was actually explaining. We use standard scalar to pre-process data to improve model accuracy. Very simple and straightforward. So, and it is actually because we use it when there is scale inconsistency in data, such as a feature being 100 or 1,000 greater than the other, just as we have it in our case. So that is the answer to this question. In case you come across it, who knows, in your interview. So I wish you the best. Thank you so much. My name is Oluwasegun Adebayo again. So I hope you learned something and hope to see you in the next video. Okay? Thank you so much. Bye.